So in this demonstration, we're going to take some of the problems you've just dealt with in Practical 2 with the dinosaur speed velocity question and take them further. In particular, we want to look at how Excel can help us calculate complex equations with multiple input variables to give us multiple results. So taking the dinosaur velocity problem, we're going to improve it. So in your previous practical, I stated that h, which is the hip height, was defined by 4f, where f was the footprint length. Now in reality, h is better defined by equation 1 over here on the left, where h equals 3.6 to 5.9 times f. So this 3.6 to 5.9 is a range of values, or possible values. So how do we calculate h? Or more specifically, how do we calculate the full range of values that h could be? Well, first of all, let us define this range, the 3.6 to 5.9, as h colon f, which I've added in my table here in Excel. So the first thing we want to do is enter in this column from A5 downwards all values of 3.6 to a maximum of 5.9. Now I'm going to increase these at 0.1 intervals. So 3.6, 3.7, 3.8, etc. So the first thing I'm going to do is type in 3.6. Now I could then type in 3.7, 3.8, all the way down to 5.9. Now this is fine if you've got a very small range, you can do that quite quickly. But say you had a range that covered several thousand individual values. You don't want to be manually typing them. So you've got several options. Now the first option is you type in at least two values to start with. So in this case 3.6 and 3.7. You select both, in this case by clicking and dragging the two cells together. And you'll notice in the corner we have this little green square. If we hover over that, our cursor becomes a cross. We can then click on that, hold down our left mouse button and drag down. And Excel will automatically calculate the change in value as you go down, as indicated by that little box on the right hand side of the green. So I just need to keep going down until I get to 5.9. I can then release my mouse and Excel will automatically fill in all those values for me. So that's one way of doing it. Now if I just go backwards, Control Z, there's another way of doing this. We can use an equation. So here we can have our 3.6 as standard. We can then have here our original value, which was 3.7, replaced with equals. So we're going to write a formula. We select the value above, which is our 3.6, and we just say plus 0.1. Enter. It calculates that. Now, if we select 3.7 and drag down, what we're actually doing is dragging that formula down. So if we select any of these values, let's select 5 down here, and then click on the formula, you'll see that by dragging the formula down, it's actually dragged the reference cell as well. So it's still referring to the cell above, and every time adding 0.1. This is a useful technique if you want to have a value of change between your cells that changes by some other value. Either way, once you end up with your range of values, in this case I'm just going to delete 6 because that's outside my value. So from 3.6 to 5.9, we've defined our range, our h colon f. We can then work out height. So here we can just do equals, and we want to times our 3.6 by our foot height. Now I've defined our foot length, f, as 0.5 up here for the moment. If I press enter, it calculates our h. And again, I can drag down this formula. However, at this point, you'll notice we have a slight problem. Here, Excel is now saying hash value exclamation mark. This is a default Excel error. It means it can't calculate the value for a reason. Normally, these are simple reasons. For instance, your formula is no longer referencing a cell. So if we click on our value here for H, which is in B6, and look at our formula, we'll see that as we drag the formula down, it also dragged down both of our reference cells. In the case of the blue cell here, where we're referencing the HF value, this is correct. We wanted it to look at the 3.7. But where we're referencing the red cell, which used to be our A2 cell, it's now referencing a blank cell. This we do not want to happen. And similarly, if we go to the value one and look at that, you'll see that it's trying to times the 3.8 by the text H:(F). This is why we're getting a value error. It can't times a text field by a value. How do we solve this? Well, what we need to do is go back to our original B5 field and our calculation, and we need to lock our A2 cell to always be A2 as we drag our values down. We don't want to lock the A5 cell because that we do want to change as we go down. How do we do that in Excel? Well, Excel uses the dollar symbol to lock its fields. So if we want to lock that field to the A column, we put a $sign in front of the A. If we want to lock our A2 to the 2 row, we put a $, in front of the 2. Press enter. You'll see nothing's changed in our value, that's still working. But this time when we drag the field down and release, it's actually calculating the values correctly. And we can test that. Let's just select this value here, which is B19. So that should be referencing our 5 value here in A19 and should still be referencing our A2 value up here. If we click in the formula bar, it indicates which fields we're referencing, and these are correct. So using that $ symbol in your calculations makes your life a lot easier. It also allows you to do these more complicated calculations with reference cells that are not moving versus reference cells which are moving. Now we have those values in place, we are ready to calculate the velocity of our dinosaurs for each of these different hip heights. So we're going to use the equation over here, equation 2, where v equals brackets 2.5 times gravity to the exponential of 0.5, close brackets, times the stride length to the exponential of 1.67 to the close brackets times the hip height to the exponential of minus 1.17. So this is quite a complicated calculation. So we'll start typing that in under my v column for velocity. So equals to start with, and here I'm going to start using brackets straight away. So I'm going to bracket up to start at the first part, and 0.5 times 9.8, and then the hat symbol, which is shift 6, 0.5. So that's the first part. We're then going to times that by the stride length to the exponential of 1.67. So for that, I want to select the stride length. Here I put it in B2. So I select that. And that again is to the exponential. So shift 6 to get the little hat symbol. And then 1.67, close brackets. Then I want to times that by the h value, so the hip height we calculated, which is in our B5 cell for this particular velocity. And this is to the exponential of minus 1.17, close brackets, and press enter. It's now calculated the velocity for this hip height with this stride length. So once again, we can then drag this down and try and calculate all the values for all our different hip heights. But also, once again, I have forgotten to lock some of our cells, which is why we're getting this value error. So if I go back to our calculation and look at what we need to lock, we need to lock our stride length, so it's always referring to B2. So if I go back to the calculation and put in some dollar symbols around our B and our 2, locking it to this row and this column, and then press enter. Now redrag. We now have a set of calculated results for all these different hip heights at this stride length. Now, of course, we can change the stride length like in all our other equations. So say I had stride length slightly bigger with 4, it now recalculates them all in bulk. Same as we could recalculate for a stride length of 4, but maybe with a foot length. Let's go for a massive 1 meter foot. Again, it's recalculated everything for us. So this is how you would set up your table in order to calculate a large number of complex equations with multiple variables. Now we can take this one stage further. Currently, we're calculating what I would describe as a one-dimensional grid. We have a single variable that can change in the stride length, and that calculates this set of velocities for our pre-calculated hip heights. Now say we wanted to calculate every velocity possible for every stride length within a range, for every set of hip heights within a range. So this becomes a two-dimensional grid, which I set up here. So for every stride length, which I've labeled S1 to S11, where my stride length is going from 2 up to 4 at 0.2 intervals, and for every HF value, which is from 3.6 to our 5.6, we want to calculate the velocity. So in this case, what I want to do to start with is just copy and paste our original equation 2, which we had in our previous worksheet. So if I go back to our 1D grid, go to the top velocity one here, I can just copy the whole of that equation. Note that I'm actually copying and pasting from the function bar, not from the worksheet. This allows me to copy the actual written down equation we put in, but not the value. So Control C for copy. I can then go back to our 2D grid, click on the cell I want, click in the function bar, and click paste. Now if I go enter, it's going to come up with this error saying that I have references which no longer exist. And this is true. This is because we've moved the formula. So I can't just hit enter. What I've got to do first is edit this formula. So if I go back to the formula here and find where the errors are. So at the moment we are referencing a stride length of B2. Now B2 has nothing in it. What we actually want to be doing is referencing our value B4. So if I change 4 there from the 2 and press enter, then go back and now highlight the formula, we are now referencing the correct cell for the stride. I'm also referencing B5 here. Now B5 is actually itself. We don't want that. What we want B5 to be is our H calculation from equation 1 over here. So instead of B5, what I want to do is open 2 more brackets, and I want to type in our range value, which in this case, we're going to take the range from A5, and we want to times that by the foot length, F, which is A2. Now A2 we want to be stationary. We do not want that moving every time we drag it, so we're going to lock that one completely. Equally, we want to lock our HF value to only be in column A. We want it to be able to drag up and down, but not left and right. So in this case, we want to do a slightly more specialized $sign placement. And in this case, we want to actually lock the column only, but allow the row to move. So by only having one $sign in front of the letter for the column, we're only locking the column. And similarly, on that vein, we want to make sure that when we drag our cells to the left and right, that our stride value drags with it. But we want to make sure that it's always on row 4. So this blue box should only move left and right along row 4. So in this case, we currently have both the column and the row locked. We want to remove the locking on the column. So we only lock the row. We can then press enter, and it's now calculated our value. Now this is the velocity for a foot length of 0.5 with a HF value of 3.6 and a stride length of 2. We can now drag that down, and it's now calculated our velocity for all the HF values down here for our stride length 2. Now the advantage of having spent all that time getting the locking of the columns in the row correct is that it means we can now drag to the right. It's now filling in all the values for all our S stride values, for all our HF values. So if I was to go down here and randomly select stride 10, which is 3.8, at a HF value of 5.3 and look at the formula, you'll see that it's selected 3.8, 5.3, and is still using our F value of 0.5. This means that if we wanted to, and we wanted just to change the foot length slightly from 0.5 to 0.6 and recalculate the entire grid, all we've got to do is change the F value and press enter. It now recalculates all the values for us. Hopefully this demonstrates the power of Excel if it's set out correctly. And for, as I said, calculating large complex equations with multiple variables in one fell swoop. Now we're just going to move on to something slightly different. So I'm going to open up a new Excel file. So File, New, Blank Workbook. And we're going to look at some of the built-in formulae or formula functions that Excel has. So for this example, we'll just concentrate on one of the functions available, and that's the summation function. We'll come to other functions later on in the course as we go through. So I'm just going to click on the cell, just the C3 one. I'm going to start my function. So like all equations, anything that needs calculating Excel, we start with an equal sign. And I can start typing the word sum. As soon as I start typing sum, you'll have seen all these different options pop up. These are all the inbuilt functions that Excel has. And there's a lot of them. And they all do something specific and different. For the moment, I'm just going to use sum. So once I get this far, I can just click on the word sum if I wanted to. And it will now tell me what I need to do. This is Excel's little help. So it's telling me that to use sum, I need to enter a number, followed by another number, followed by ... Now the ... just tells you that you can keep adding number after number after number. So I'm going to put 3, and then comma, 3, comma, 3, comma, 3. So what we're asking it to do is summate 3 plus 3 plus 3 plus 3. To finish that, I need to close the brackets and press enter. It's now calculated 12, which is correct. So that's summation, a simple function. But we can do more than just type in numbers into a predefined function. So say, for instance, I start with a column of numbers. Here I'm just going to start with 2, 4, and I'm going to drag these down. So we get a decent number. So we got a range of values from 2 to 50. Now say we wanted to summate all of those values. Well, we could start typing an equation that is similar to this, plus then this one, plus then this one, plus then this one, etc, etc, etc. Time consuming. We don't want to do that. So we go back to our sum function. So we start typing sum, we can open the brackets. Now yes, we could, again, select each one individually. So A6, A7, A8, etc, etc, with a comma in between each one. Now if I just close the brackets quickly and we just count out those top 4, press enter, it does work. But again, that's slow. We don't necessarily want to do that. So I'll just delete that and we'll start again. The quickest way is to use something called ranges. So I type sum, open brackets, and instead of having individual numbers, what I can do in Excel is define a range of numbers. Or more precisely, a range of references to those numbers. So if I start at A6 and I just drag down to my bottom value, which is A30, you'll see that it's actually added a range in. In this case, A6 colon A30. I can close the brackets, press enter. It is now summing up this entire range of values. And this works on columns, on sets of data across multiple columns, depending on the function, or across rows, or multiple rows, again, depending on the function. So ranges in Excel are incredibly powerful. Now, with all these built-in functions, you can include them within your own equations. So if we take this summation at the bottom here of all our values, which gives us a result of 650, we can go to our formula and say, for instance, we wanted to add an extra 50 to our entire sum. We can just add that onto the equation. So in this case, plus 50. If we press enter, we now end up with a result of 700. So it's a very versatile system. And we'll get on to how we access all the other functions, how we work out which functions we need, how we can search for functions and get help on functions in the next demonstration. But for the moment, we're just going to return to our dinosaur practical just to show you one last trick. So I'll just minimize this window and come back to our dinosaur one. Create a large data set. Is I'm just going to increase the number of columns we have here. So I'm going to add some more S values in, some more S headers. I'm going to drag our calculation across. And similarly, I'm just going to increase the number of HF values a little bit. And again, just drag down our calculation so we fill up our entire data table. Now, the reason I did that is to demonstrate how we can view our data separately from our column headers. So currently, when we scroll up or down, using either the sidebar or a scroll wheel in the mouse, or go left to right, everything moves. Sometimes you want to keep our headers of our column fixed and our columns, for instance, down this left-hand side with A, also fixed. So to do this, what we want to do is go to View, Split, and you'll see that we get these little bars appear. We can drag these to where we want to put our fixed columns and fixed headers. What they are in fact doing is creating these individual panels, each which can be scrolled separately. So now if I scroll this bottom one, you'll see that our A column is fixed. Similarly, if I scroll up or down, you'll see that our S rows are also fixed. depending on which scroll bar we use. Now we take that a stage further by pressing this Freeze Pane button. And this gives us the option to freeze panes in various different configurations. If we choose the top one, having had the split in place, it changes those thick bars to these slightly darker lines, but still thicker than your general grid. But our scroll bars have now come back to only being one vertical and one horizontal. And our column headers are still static, depending on which one we use. So this is a good way of being able to view your data when you've got large data sets and you still want to see your headers and row titles. A final thing just to cover while we're here is how do we bulk clear our formatting? Say for instance we formatted a large table but we want to clear it down to its raw values. Well, in this case we have all these formatted headers. What we can do is select them. We can then go to our ribbon menu at the top here, go to our home, and we can come across to this right hand side and we have this drop down clear option. We can clear all, we can clear the formats, which is what we're talking about at the moment. There are other options, for instance, of clearing the actual content, so this gets rid of the raw data. If you have comments or notes you've added in, or hyperlinks, these can be cleared separately. For this, I'm just going to clear formats, press that. It returns the data to its raw state without any formatting. Another thing, while we've got all this data available on screen, is to show you how to insert and delete columns. This applies to rows as well, but I'm just going to show it on columns. Say for instance we wanted to insert a row between I and J. What we can do is highlight J, we can right click and we can say insert. And what this has done is inserted a column where J was and moved everything from J to the right along one cell. So everything that was in J is now in K, everything that was in K is now in L. You'll also note that it's updated all the formula automatically for all these cells that have moved. Deleting a column is equally simple. Highlight the column you want to delete, right click, say delete. An alternative way of doing that is to go up to our home menu at the top here, across to where it says cells in this area here, and we have these insert, delete drop downs. We can tell it to insert columns. We could then tell it to delete the columns. This is exactly the same as using the right click method.